Okay, good morning everyone. So myself Deoproto Das from Tumkanjin College. Today we'll take the subject is control system, and we have continue our topics, that is the compensation design.
Good morning, sir.
Yes, good morning. So just wait, I am starting. Okay, so let's start. We have discussed in our last classes, that is the compensation design of control system. Okay, so just recall, then we have to continue our next part also. So what is the basic necessary of the compensation network circuit? Okay, so why you have to design for compensation network in control? Because you know that we have we have also discussed in our previous 3-4 module, that is the stability analysis of control system. Okay, so in this module we have to consider, we have to accept the different, we have to collect the different idea from the different method. That is, we have to collect the idea, that is the Bode-Bloch, Root-Lucas method, okay, signal flow graph method, route stability criteria, Nyquist criteria, etc. So in this module we have to discuss the stability analysis of a given characteristic equation in our control system. So after that, we have to also connect one compensation network circuit in this control system. So this is the basically necessary of the compensation network we have discussed in previously. So in order to obtain the desired performance of any given system, it is applied to the system in the form of feed forward path for the gain adjustment. And number two, this compensation circuit is compensate a unstable system to make it stable. That means when you have to use a unstable system, you have to collect the result by frequently it is also some error is coming or something, sometimes it is not stable. So in that case, we have to use as a compensation network circuit for stability for the control system. Number third, a compensating network, it is used to minimize the overshoot error. Okay, you know that in our control system there are lots of errors we have to calculate. Okay, so this is the basically uses of our or necessity of our compensation network or compensating network we have to use to minimize the overshoot error also. And compensating network, it increases the steady state accuracy of the system. This is very much important point. So this compensating network, it is increases the steady state across the overall systems also. And it introduces poles and zeros in the systems, thereby causes any changes in coming in our transfer function of the given system. So these are the basically necessity of the compensation network also. Then we have to classify these compensation network according to our design, circuit design oriented. This is the first one, series compensation. Number two, feedback compensation. And number third is load compensation circuit. So first we have to calculate the series compensation circuit. Okay, so you know that this is the basically one block diagram we have to discuss in our previous classes. This is the series compensator circuit. So in this series compensator circuit, you have to see there are basically one closed loop control system we have to consider here, because you know that here feedback loop, one feedback we have to attach in our control system. This is the output to the error signal, that is the first summing point where we have to connected the input to the compensator also. So this is the input, that is the RS input of the system. Okay, this is the first summing point where we have to connect it one compensator circuit. This compensator circuit we have to also classify it in our circuit design. We have to consider in the next slide also, or next classes also. Then we have to connect it this is the GS. GS means that is a process or plant also. Okay, and then this process or plant, it is going through a closed loop connection, that is a feedback loop connection. We have to express here that is H phase. You know that when any unity feedback we have to attach in this control system, this is called the unity feedback system. That means the feedback factor, it is equals to 1. Okay, so this is the basically block diagram of the series compensated circuit, and it connecting compensating circuit between the error detector, this one, that is a ES, and planned, it is known as compensation circuit. Okay, is it okay, all of you?
Yes, sir.
Okay, so next we have to consider the feedback compensation circuit. Okay, sorry, this is a block diagram of the feedback compensation circuit. You know that here you can see this is a basically processor plant. We have to connect it in parallelly also compensator circuit, and also feedback, it is also attachable here. But in this feedback compensator circuit, you have to see there are two summing points we have to add. First summing point, this one, it is connected to the input of the system, that is RS. Another one, it is connected to the this feedback loop, which is also attached, and this is also connected another part, that is another summing point also. And next, this number 2 summing point, it is also connected between the processor plant, another one is the compensator circuit. Okay, so this is the basically feedback compensator circuit, and sometimes it is also, sometimes it is called parallel compensator also. Okay, so when a compensator, it is used in a feedback pattern or feedback manner, it is called the feedback compensation or parallel compensation circuit. Okay, next, number 3, we have to discuss load compensator circuit. So in this circuit here, you can see these are the basically same to same feedback, but here only we have to attach one another summing point. It is a process between the processor plant to the output of the system. So these are the basically same of the first we have to discuss series, and second we have to discuss the feedback compensator circuit. So a combination of series compensator and feedback compensator, this circuit is called the load compensator. Okay, is it okay, all of you? So one
Yes,
question.
sir.
Yes, thank you. So one question, it is also coming in your semester question papers. So what is the different method you have to use for compensation network? So at that time you have to discuss these 3 of compensation circuit with the diagram also. Next, this is the another part. This is the main questions of this chapter. This is the classification. What is the classification of the compensation circuit? So according to that, we have to design 3 type of compensation network in our control system for stability purpose. Okay, first one, that is a phase lead compensation circuit. Somehow we have to start in previous classes also, and we have to continue in this part also another. Number 2, we have to discuss this is a phase lag compensation network circuit. Number 3rd is phase lead lag compensation circuit. So in this case, previously we have to use only lead compensation network. Number 2, we have to design lag compensation circuit, and third is these are the basically lead network plus lag network. This is called the phase lead lag compensation network. Okay, so this phase lead compensation circuit we have to discuss in previously. This is a basically simple circuit we have to design for the phase lead compensation design. Okay, so a system which has one pole, this is a pole, and one dominating zero, it is known as the lead network. So if we want to add a dominating zero for a compensation network in our control system, then we have to select the lead compensation network. So in this description, you see that why you have to use in your control system is lead compensation network, because when any system it has a one pole and one dominating zero, we have to use as the lead network also. And Another, we have to add a dominating zero in this compensation network for the control system. Then we have to select also this type of phase lead compensation circuit. So in this circuit here, you can see this is the input, this is the output. We have to express at EI and E0 also. And we have to use one capacitor with the parallel connection of this resistor, that is R1. And the output, it is coming from the load resistor, that is the R2. So we have to explain, that is a phase lead compensation network. From the circuit we have to written, that is I1, this is the I1, and this is the I2. Okay, so this I1, it is equals to C ddt of input, difference between the input and output of the result also. Then this is the I2. This I2, it is according to the corresponding to the R1. So this is I2. This is equals to EI minus E0 by R1. So this is the basically we have to calculate it separately. First one, that is the I1. Second one is the I2. So we know that I is equal to I1 plus I2 also. So then you have to put this value and this value also. Then we know that this is the total current of this phase lead network circuit, that is I, this is equals to with respect to the load resistor, that is the R2, that is E0 by R2. Okay, up to this part it is okay, all of you?
Yes,
Please,
sir.
please respond everyone, not only for class for Richika. Okay, so because all of you present in class, but you not respond the class timing also. So please respond everyone. मतलब क्लास में आ जाते हो आप लोग ऑन करके, मोबाइल को छोड़ के या लैपटॉप को छोड़ के आप लोग बाहर घूम रहे हैं, ऐसे नहीं चलेगा बेटा, ठीक है? ये है, ये जो चैप्टर पढ़ रहे हैं ना, इसी से एक को क्वेश्चन आएगा, ये आपको मतलब जिंदगी भर आपको काम में लगेगा, ये वाला सर्किट, ये कंपनसेशन डिजाइन. ओके, so please everyone read this also carefully and accept it, and also response is given is very much important. Okay, so next part, we have to also equating this above expression, sorry, above this expression according to this, we have to calculate the total current, that is I. Then we have take the Laplace transform in the both side. Then we have to, you know that the after Laplace transform you have to apply one by one, this one also, this one also, input and output sections. Then we have to calculate it. This is the output of the system by input of the system. This is the total calculation we have to discover in our last class. So this is the basically last equation. Just wait. We have to continue our next part from here also. My whiteboard is visible, everyone?
Yes, sir.
Yes, sir.
Okay, okay. So we have discussed the topic name is phase lead network. That is the continued part in the previous classes also. So in the previous classes, we have to discuss the output of equation. I'm written here. That is output of the system E0S by EIS. We have to calculate a previous result, that is R2 by R1 plus R2 into this is 1 plus SC R1 divided by 1 plus S R1 R2 C by R1 plus R2. This is the basically phase lead network circuit of the input to the output of the system. Okay. So on substituting, the alpha we have to express here also. This is R1 plus R2 by R2. And this T, it is equals to, that is R1 R2 is divided by R1 plus in the above equation. Okay, so we put this alpha and T, we have to put in these equations also. Then the equation is coming, we have to express here. This is the transfer function. Okay. We have expressed here, that is the lead network of the system. That is G lead means, that means transfer function of the lead network circuit. This is equals to, we know that output of the system to the input of the system, that means E0S by EIS. And we have to express this equation, we have to written, that is 1 by alpha into 1 plus alpha ST by 1 plus. Okay, so this is the basically transfer function of the phase lead network circuit. That is the transfer function G lead S, that is the E output of the system by E input system, that is 1 by alpha equals to 1 plus alpha ST by 1 plus ST. So this above network we have to visualize as an amplifier and gain of the 1 by alpha. So the above network can be visualized as an amplifier as an amplifier okay, with a gain of 1 by alpha. Okay, so this is the basically complete transfer function of the phase lead network circuit. That is the G lead, the lead for the lead network circuit of the system. It is equals to the ratio of the, you know that, transfer function ratio, it is output to the input of the system. That is E0S by EIS. So from the above equations, we have calculated, this is 1 by alpha, this is equals to 1 into 1 plus alpha ST divided by 1 plus ST. Okay, so this 1 by alpha, it is a network in this phase lead network circuit. It is visualized as the amplifier gain of the lead network circuit also. So in the diagram, just you can see, I'm drawing a one design for the network for the phase lead network circuit. This is the, you know that real axis are, this is the imaginary axis, you know that previously all of you seen. So in this circuit, we have to express, this is a state plane, this is a imaginary axis, sorry, and this real axis we have to express here delta also. So this is the center point, that is a 0, and here we have to consider, you know that in the phase lead network circuit we have to consider one pole and one dominating 0 also. This is a -1 by alpha. So this is the pole 0 figure. Pole 0 of lead compensating network. Okay. Is it clear, all of you?
Yes.
Sir.
So in your exam, either phase lead network circuit or phase lag compensation circuit, you have to design. Okay. So this is the basically expression of the phase lead network. So now we have to discuss what is the basic effect or what is the basic applications, and then we have to discuss the advantage and disadvantage of the phase lead network. Okay. So first, what is the effect of this compensation? Phase lead compensation. Okay. Number one, the velocity the velocity constant with respect, we have to express the velocity constant. You know that is kv. It is also increases. Number two, the slope of the magnitude plot reduces at the gain crossover. So that relative stability improves and error decreases due to the slope. Okay. So the slope of the magnitude plot of the phase lead network circuit, it is basically reduces the gain crossover frequency. Okay, so that's why we have to use this relative stability in the phase lead network compensation circuit. It is improves and also error, it is also decreases. Okay, so that's why we have discussed in our previously in the necessity part of the compensation design. So it is basically reduces the overshoot error in the control system. Number third, the phase margin increases. And number four, its response, it becomes fast also. Become fast or faster. So this is the basically effect when you have to use any phase lead network or compensation design for our control system. Okay, so its response is very fast. Phase margin it is also increases, and also any overshoot type of error it is decreases using the phase lead compensation network circuit. And this phase lead network compensation circuit, the velocity constant, that is a kv, is also increases. Okay. Next, what is the advantage? Why you have to use this lead network circuit? What is the advantage? Okay. So the point is advantage. Sorry, 1 minute. Of phase lead compensation. Sometimes it is also called the network. Okay, that is a phase lead network circuit or phase lead compensation network circuit. So these are the basically same. So why you have to use this lead compensation circuit? Number one, due to the present of phase lead network, the speed of the system increases because it shifts gain cost over to the higher value. Okay, so first it is due to the presence of phase lead network circuit, the speed of the responses is very much faster. So this speed of the system it is increases. Okay, and it shifts gain cost over frequency to the higher value. So that's why we have to use this the phase lead compensation circuit also. Number two, due to the presence or present phase lead network, or compensation, maximum overshoot of the system decreases. Okay, so these are the basically advantage we have to use for control system for the stability of the system. Okay, so first, due to the presence of the phase lead network circuit, the speed of the response it is very much faster over the lag network, and it saves the gain cost over frequency in the higher value ranges. Number one, and number two, this phase lead network circuit or compensation circuit, the maximum overshoot error it is decreases for the control system also. So this is the basic, very much important advantage in our compensation design circuit. Okay, so that's why we have to use this lead compensation circuit. Another one, what is the disadvantage? Okay, disadvantage of phase lead network or compensation. So some of the disadvantages are present in this phase lead network circuit. So the important is steady state error. This is another one. You know that steady state error is not improved by use this phase lead compensation circuit. Okay, so this is the basically one important disadvantage of this phase lead network compensation circuit. It does not improve any steady state error. It is present in our control system. Okay, so that's why more or less we have to use the phase lead network circuit in our control system also. Is it clear, all of you? Lead network circuit or phase lead compensation design?
Yes, sir.
Okay,
Yes,
now,
sir.
okay, thank you. Next, we have to discuss the another one circuit, that is the lag network circuit. Okay, just wait. Next is phase lag compensation. Okay, so this phase lag compensation circuit is another one compensation design in our control system. So this system, which has 1 0 and 1 dominating pole, it is also another part of our lag network circuit also. Okay, so a system which has one zero and one pole, that is a dominating pole, is known as lag network. If we want to add a dominating pole for compensation, in control system, then we have to select a lag compensation network. Okay, so this is a phase lag compensation circuit. Why you have to use this? When any system it has 1 0 and 1 pole also, it is known as the lag network circuit. And if we want to one dominating 0 in our lag network circuit or any control system, then this compensation network we have to use this in our control circuit. It is select for a lag compensation network circuit also. So what is the basic needed when you have to design any lag compensation network circuit? So the basic requirement of the phase lag network okay, everyone write your own name and roll number in the chat box also. And Gautam is present
Yes, sir.
to take a screenshot, okay? And
Yes, sir.
after ending this class, we have another classes also. So join everyone after 3-4 minutes also. So the basic requirement of the phase lag network is that all poles and zeros of the transfer function of the network must lie on the negative real axis. Okay. One minute. So the basic requirement of the phase lag network circuit is that all poles and zero of the given transfer functions of the network, it must lie on the negative real axis, interacting each other with a pole located or on the nearest to the origin. Okay, so this is the basically little bit descriptions of the phase lag compensation circuit. I repeat once again, when a system which has 1 0 and 1 pole, it is known as the lag network circuit. And if you want add a dominating zero in this phase network circuit, or sorry, add a dominating pole for a compensation. So in our control system, then we have to use this in our lag compensation circuit. But others, when we have to consider the phase lead network circuit, so in that case we have to add a dominating zero. But when phase lag compensation circuit, we have to add a dominating pole. So this is the basic difference between the phase lead and phase lag compensation circuit. Okay. So the basic requirement of the phase lag network circuit is that all poles and zeros of the transfer functions of the network, it must lie on the negative real axis. Okay, and it is interacting each other with a pole. It is located on the negative real axis or nearest of the origin. Okay, up to this part it is clear, all of you. Next class we have to discuss the network design or lag network design. Okay, so please everyone join after 3-4 minutes. Okay, so everyone write your own name and roll number in the chat box also, and Gautam, you take a screenshot also.